Hi, everyone, and thanks for spending some of your time pondering a few ideas with me. I'm Todd Duncan, and I teach physics and astronomy at Pacific University here in Oregon. So to set the context for what I want to talk about, I need to highlight two key aspects of big history that combine to make it so valuable in addressing the challenges facing humanity. One is that it is a narrative, right? It's not just an abstract academic description of things, a sort of timeline of events. It actually is woven together and has meaning we can connect to, and it tells a story that we can connect meaningfully to in our daily lives. And so that's a key aspect. But it's also equally important, I think, that it is scholarly, it's evidence-based, and it's rigorous. Right. So that's what gives it the combination of those two is what gives it the possibility of a unifying transcultural framework for orienting our everyday experiences within a modern scientific map of cosmic history. It's right. So that it can transcend local stories and be a shared planet-wide or even galaxy or universe-wide narrative that that we can work within. So the combination of these two things, even though that's what gives the kind of the power to big history in terms of solving problems, it also is a challenge that is, I think, nicely framed in a different context for academia by Arthur Zients, who points out the importance of keeping the intellectual standards very high, but still in such a way that no view is ruled out on the basis of metaphysical pre-commitments. And I think the key point that I want to make here is that it's very easy, especially in science, probably in all fields, to end up entangling a worldview, a metaphysical commitment, with the actual facts of the science that are what make our field rigorous. And so it's very important to keep those distinguished in a way that makes sure that we can be rigorous, but also not shut off. As Zients goes on to say here, genuine solutions adequate to our problems are only going to arise from an ontology that's broad enough to embrace the richness that's the whole universe, right? So keeping that balance is important. So that's basically kind of setting the stage by way of background for my offering here today, which is an example of the kinds of places where we actually have room to expand our ontology while still maintaining the scholarly scientific rigor that's also important. So the example I want to give is, of course, from physics, because that's my field. And it's some work I'm doing with students and colleagues to address questions in the foundations of physics. And I will say, mostly in my talk, outline what we're doing to give you enough background to kind of see, hopefully, how it's a good example of what I'm talking about, and kind of set the stage, I hope, for more discussion about how it can apply in the big history context. Okay, so so the working title of our project is Physics in a Self-Consistent and Self-Referential Universe. And basically what we're exploring is, can we derive some set of laws of physics from an underlying principle that is kind of most simply stated as saying that existence must be able to describe itself, and it must do so in a self-consistent way. And this work was originally motivated by the so-called fine-tuning problem, which is basically, why are the laws of physics just right for life? And right, the idea is that if you think kind of a priori about if you were going to build a universe and you could do anything you wanted to set all of the laws of nature the way, you have dials you can tune to set the laws any way you want. You can choose the speed of light, you can choose how strong gravity is, you can choose the charges on the proton and the electron, and things like that. Out of the set of possibilities for how you could set those parameters, the subset of those that seems to fit anything we can imagine with the kind of information processing capacities for life of any sort that we can conceive of it, is a very small subset compared to the total set of laws you could have chosen. And so why is our universe in that small subset out of all the broad possibilities. So that's the general question we're working on. And that has led us to this new approach that I think also has broader applications as an explanatory framework within physics, which I'll talk about a little bit here in a minute. Okay. So the basic idea of our attempted solution to this problem is to kind of turn things around and say, the reason we're running into a dilemma is because we're assuming implicitly, kind of in the spirit of what Jenna was talking about a little while ago with how we can get stuck in our thinking process. If we've been assuming implicitly that what's really going on is there's kind of a objective material universe out there that would be just fine without consciousness as part of it, and assuming that the laws get set independently of that. And then we're kind of asking to tag on to that, well, why did consciousness then arise, and why are the conditions right for consciousness to arise? So what if we experiment with turning that whole framework around and saying, what if the starting point, the most fundamental aspect of reality, if we can, rather than describing it as some kind of material stuff, what if it's best to describe it as something that we can characterize as of the sort of what we call experience, right, or awareness? So what if, not in the kind of individual personalized sense, but just if you imagine a very vague kind of undifferentiated awareness or experience that is the starting point for things. And then if you imagine that needing to be able to describe itself, which obviously we are now doing, and if it has to do so in a self-consistent way, it turns out that that's a pretty severe constraint on what's possible. And so if you imagine starting from experience, and then what we call the physical and material world and the laws of nature are basically the patterns, the rules that arise as necessary if that experience is going to be able to describe itself in a self-consistent way, that becomes our framework for explanation, right? That we work within these, we sort of describe what the experience level constraints are first, and then try to map that onto a physics level, conventional physics level description. So that's kind of the program of our research. And it's a very pragmatic approach. I guess I just want to point out, there's obviously a very long and interesting philosophical history of the idea of idealism, and having a universe that starts with consciousness, and that the material world is sort of derivative from that. And as I said, all of that is, of course, very interesting and important. We're taking a very pragmatic sort of problem-solving approach of just saying, let's just try this as a hypothesis. What if we start with this assumption, and where can it get us? So we're interested in what kinds of problems become solvable by starting with experience as fundamental. And obviously one of them is, why is the universe just right for life? That's what motivated our interest in this. And here, it's clear that it solves that problem, because that's how it's designed to solve that problem. And basically there, the shift in perspective just untangles the problem by noting that we created it in assuming that we could have consciousness, we could have existence without awareness. And closely related, the so-called hard problem of consciousness from philosophy essentially dissolves in this framework, because we're no longer trying to explain how experience arises out of a fundamental reality that's devoid of experience. Instead, experience comes first, and what we call matter and laws of nature are just the patterns that arise as requirements for experience to be able to describe itself self-consistently. Part of the value, I think, of this, though, is that it opens up a realm of any of the kind of foundational questions in physics that amount to some version of why are these laws the way they are, is amenable to solution from this approach. Essentially, the framework is, perhaps they are as they have to be in order for experience to describe itself self-consistently. And there's a long history in physics of this kind of approach to problems, not with consciousness involved, but relativity is probably the classic example, where you start with a kind of simple underlying principle, like the idea that all observers see the same laws of physics, regardless of their frame of reference. And then from that, you can derive the Lorentz transformations, which are the seemingly counterintuitive rules about how space and time transform in different reference frames. And Ravelli and lots of other people are trying similar approaches to derive mathematical rules of quantum mechanics from a simple underlying foundational principle. So we're following that same kind of recipe. The only difference is really that we are trying it with different starting principles to see where that leads us. Okay. So one of the most intriguing areas of what we're working on for me is that, just to give you an example here, is that quantum mechanics, so quantum mechanics is, often described as being very counterintuitive. And yet, if you think from this experience level perspective and you ask, how would you implement a universe that combines rule-based and non-rule-based aspects of experience, which both seem kind of necessary for being able to have both predictability and creativity in the world? That's not easy to do. It's not easy to combine those self-consistently. And quantum mechanics, the formalism of quantum mechanics, looks like sort of a perfect implementation of such a combination of those two things. So that's kind of an intriguing idea to explore. And just to kind of give you a concrete picture of what the work is that we're doing, I made this little table to highlight, this is the mapping that we're working on. And these are just a few examples I picked of the kinds of things that you can map, where you go from trying to describe the universe at this experience level as things like, well, we need a filing system to organize different experiences. And so that could be what space and time are in the conventional physics terms. And I already mentioned the quantum mechanics example, and there are lots of others. So again, that's the kind of program that we're working on. Okay, and then obviously we can talk a lot more about that research area if people are interested in the discussion. And I wanted to bring it back to an example of what Jenna was talking about, of just how this shift in thinking can really impact our how we approach things. And so here's a long-standing kind of example from philosophy. One version of it is nicely stated by Owen Flanagan, which is and it's, in a way, it's kind of what drove my interest in science, is trying to make sense out of, as we understand the universe currently, what sense can be made of my wish to live a meaningful life if we're material beings living in a material world, right? Those seem contradictory. And there's a sort of a sadness, I guess, right, or sort of a lament about the situation. How do we find meaning in this world that we exist in? And yet, notice what happens if you shift the words around in our kind of new framework here. Then material becomes just a way of describing the orderly, patterned, lawful aspects of experience. And the concern essentially dissolves, right? Because if you reword it in those terms, now you're saying, what sense can be made of my wish to live a meaningful life when I'm constrained by the patterns of experience that are necessary to describe itself in a self-consistent way, right? So it almost becomes not contradictory to a meaningful existence at all. It's exactly what's needed for that meaning to unfold in some way. So anyway, just an example, like I said, that we can talk more about of the shift in thinking, still maintaining the rigor of the science, but just a different metaphysical commitment about how we think about it. And I just love this quote from Louise B. Young that kind of expresses the essence of what I'm getting at here and how I think it ties back into what we're after in trying to solve problems in the big history framework, that how we understand our role in the cosmic process is perhaps the most important thing in shaping how we will direct our future. All right. So obviously there's a lot to explore within this framework, and I'm looking forward to discussion with all of you about this. And in particular, I think it would be useful to explore how these ideas about the nature of ultimate reality might influence the framing narrative of big history in a way that influences what the problem-solving context that we apply. So thank you for listening, and I will leave you with some of the references in case you want to follow up on any of these ideas.